Assalamualaikum and good day to jurists and my fellow friend. My name is Muhammad Azri bin Abdul Aziz and I'm a leader for Group 9. Today we are going to present project presentation. The title is Smart Irrigation System. Our mentor is Dr. Ahmad Sayuti Abdul Rahman.
My name is Ko Ying. I will start with Chapter 1 Introduction. According to statistics, agriculture uses 85% of available freshwater resources worldwide, and this percentage will continue to be dominant in water consumption because of population growth and increased food demand. Global segment of traditional farming includes wastewater. Water is irrigating or flowing directly into the land. Besides, require human resource since the water reservoir is far away, it wastes time and energy. Farming system available in market is expensive in terms of budget. The objective of our smart irrigation system is affordable, reliable, and can be used in area which is away from electrical grid or power system. Smart irrigation system make watering schedules and run times automatically to meet specific landscape needs. Smart irrigation system has been designed to overcome the unnecessary water flow into the agricultural land monitored by sensor, which relate Industrial Revolution (IR 4.0), Internet of Things (IoT). SDG Goal 12, which is responsible consumption and production, are about promoting resource and energy efficiency, sustainable infrastructure, and providing access to basic services, green and disease jobs, and a better quality of life for all. Chapter 2 Need Analysis Market Survey to focus on outlining current available products of existing precision farming system. To understand the key performance of the product towards obtaining customer requirements. To determine the best feature among the three selected which performance best suit customer requirements. Benchmarking of competitive product. The first product is Gardena Micro-Grip Irrigation System. It's a timer-based irrigation system that is powered by a battery in order to supply water to the plant. Next product is Manual Simple Irrigation System with Fertilizer Mixer, which is a simple manual watering system that requires electrical from the power grid. Last product is TBHR Smart Sprinkler Control, which is a Wi-Fi based sprinkler timer used to irrigate farms. Design of market survey. There are 50 respondents through questionnaire for survey. The questionnaire is generated through Google Form where it gives advantage in terms of reaching farmers, especially those that stay in rural areas. These two charts shows the customer requirement of respondent for the irrigation system. In the chart shows the question we asked in the Google form. Feedback of respondent to smart irrigation system. It shows the percentage of smart irrigation system should be environmental friendly is the highest percentage, 72%, and shows that it is the main priority for the system. Following with the second highest percentage, 68%, is smart irrigation system can minimize water usage and can save time. The third highest percentage, 66%, is that smart irrigation system use low electricity usage and can reduce manpower. The table shows all the respective weightage of each criteria: minimize water usage, save time, low electricity usage, environmental friendly, and reduce manpower are rated as weight of 5 due to their high demand. Weightage of criteria with weight of 4 is the criteria above 60% and weight of 3 is for criteria 60% and below. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nordalila Arina binti Muhammad Fauzi. I will explain about Chapter 3, Design Specification. In Chapter 3, we have House of Quality. House of Quality is a kind of conceptual map which provide the means for planning and cross-functional communications. It is used to define the relationship between customer desires and the product or company capabilities. HOQ diagram use a design that resembles the outline of a house and can be created using technical and competitive benchmarking data. HOQ considered the primary tools and used during quality function deployment to help facilitate group decision making. As we can see from the chart, it is contain customer requirement on the left side and design requirement or engineering characteristics on the upper side. Based on the chart, cost is the highest among other engineering characteristics, follows by volume of tank on second place and durability on the third place. From this, we know what is the most important to the customer. This is the product design specification or PDS. The PDS is the basic control and reference document for the design and manufacture of the product. It is a statement of what the product should be and should do. The PDS is created during the problem definition activity very early in the design process. There are product identification, special features, key performance target, service environment, market identification, financial requirement, life cycle targets, manufacturing specification, key projects deadlines, social, political, and legal requirement, and lastly, physical description. Next, we move to Chapter 4, which is Concept Generation. In concept generation, there are physical decomposition, which is a physical decomposition is a process of separating the product or system directly into subsystem, subassemblies, and components to describe the parts joined together to create the behavior of the product. From this picture, we can see smart irrigation system has three subsystems, which is mechanical subsystem, control subsystem, and power supply. In under the mechanical subsystem, there are pump and valve, which is we use pump and valve to operate the water. Under control subsystem, there are Arduino and sensor. Arduino is a microcontroller that have USB connector and power port. For sensor, we use humidity and water level. For power supply, we use battery and solar panel. This is the systematic design. As we can see from the figure, there are solar energy, water, mechanical energy, and human energy. Produce water and water the crop. Next, we have function blocks. The figure shows the function blocks of smart irrigation system. The function blocks represent the importance of each function of the device that is being used. There are three concepts that we have proposed. After a few discuss and admitting among members, we agreed to choose concept 1. Next, design parameter and constraints. An important part of the problem recognition phase of the design process is to identify important design issues or parameters for considerations. This will form the criteria against which we will evaluate the design alternatives. In a project report, we need to identify which parameters need to be considered and additional parameters that need to be added to the list. First, we have economical constraints. Then, we have environment constraints. Last but not least, sustainable constraints. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is Nur Shafika binti Cik Rashid and I will continue to present about chapter 5, which is conceptual design. In this chapter, the best design on the concept generated will be determined by several methods. These methods include weight decision metric, analytical hierarchy process, and path chart. Through this method, final decision can be made from all the alternative generated from a previous chapter. So here is path chart. Path chart is a simple design tool for comparing design ideas against design criteria. This method is for identifying the most promising design concept among the alternative generated. It compares each concept relative to a reference or datum concept, and for each criteria determines whether the concept in question is better than, which is sign plus, or than, negative sign, or about the same, which is as a reference concept. So here, Gardena micro drip irrigation system. The existing product has been chosen as a datum for the path chart. Concept 1 is obtained the highest total weight, which is 2, while concept 2 is obtained 1, and concept 3 is obtained negative 1. So the second path chart is created to determine the best final concept by using concept 1 as a datum. Concept 3 is showing relative weakness, friendly, and reducing manpower. The total weight score of concept 2 and 3 obtained by negative values. Thus, concept 1 is the best concept among the other concepts generated. The next is a weight decision metric. A weight decision metric is a tool used to compare alternatives with respect to multiple criteria of different level of importance. They are a list of values in rows and columns that allows an analyst to systematically identify, analyze, and rate the performance of relationship between a set of values and also information. The metric is useful for looking at large masses of decision factors and assessing each factor's relative significance. A rating for each concept at each design criteria is obtained by multiplying the score and the weighting factors. The overall rating for each concept is the sum of this rating. So the rating for each concept has been obtained. From the table, we know that the weight decision metric indicates that the best overall design concept would be the highest total, which is design concept 1 with rating 7.82. So we proceed to the next method, which is analytic hierarchy process. Analytical hierarchy process methodology for making a choice from among a set of alternatives when the selection criteria represent multiple objectives, have a natural hierarchical structure or consists of qualitative and quantitative measurements. The function of AHP rating systems is to create the initial comparison metric as shown in this table. So, AHP process determining criteria weight is a complete criteria comparison metric using rating 1 to 9 that are described in this table. So for the last one, the selected design concept. As you can see here, conceptual design 1 is selected as the final design project. It is selected due to making complex decisions using AHP, weight decision metric, and path chart that consider important criteria. The criteria were obtained from the result of HOQ based on engineering judgment. This design consists of components which are Arduino Uno, electrical pump, capacitive moisture sensor, water level sensor, polyethylene tank, and also battery. That's all for my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zulhusni bin Muhammad Rais. Nombor metrik 18111087. So I want to discuss about abdomen design. So first is irrigation system, which is divided to three subsystems that define the overall system, which is mechanical system, control subsystem, and power supply. First is mechanical subsystem. It consists of pump, valve, and it designed to transport and control irrigation from source to crop. Then second is control subsystem, which the main component is Arduino and sensor. Arduino capacity, moisture and sensor and water level sensor were chosen. And lastly, solar power system are employed to provide self-sustainability to irrigation system. The microcontroller and solar valve in the irrigation system require electricity to operate. Electrical energy converted by the solar panel will be stored in rechargeable battery. Next is product architecture. Product architecture relate to function element and function structure. First, solar energy is captured by solar panel and converted to electrical energy. Then, in the water collecting module, it consists a tank and pump that has function to extract water from the source. Then, sensing module consists of water level sensor and moisture sensor. These sensors have their own function and we send signal to microcontroller for further operation. Then last, the water control module consists of valve will be activate when it receives signal from microcontroller. So this is block geometry layout, and real prototype design. Configuration design. Configuration design problem is mechanically involved finding optimal assembly of component that realize some of desired performance criteria. It is a type of operation of conceptual design in which physical design form a set predefined element, structure, and
I will
synthesizer.
continue to detail design and
In
prototyping.
configuration
In this
design,
phase,
there are
design
part
will refine,
layout.
plan,
The part layout is process where all
specification,
part
and
of
estimation
component
are
combine
created.
to become one product. There are
Schematic
several
drawing.
parts and components needed to build
Simple
smart
circuit of
irrigation
smart
system.
irrigation
Different
system
parts
are
and
shown in
components
the
have their own
schematic
function
drawing. In this
to
system,
support
we use
the
two types of
operation
sensor, which
of the
is
system. The
water
following
level
table
sensor,
will show you
salinity sensor, solar panel,
the part
solar charge
that we
controller,
use
battery,
in
solenoid valve, water pump,
our
and a relay.
project.
Each component has
So
its distinguished
there are
function
8
in order
main
to
parts
establish
that we
the
use
entire system.
in
Drawing. The isometric view of smart irrigation system are drawn using CATIA, which is computer-aided three-dimensional interactive tool that consists of a water tank platform, solenoid valve, solar panel, battery, microcontroller casing, and water pump. Engineering analysis. The three-dimensional model of smart irrigation system are translated to ANSYS workbench in order to perform analysis. The analysis done is static structural, which is to analyze the total deformation of water tank platform, or we can call it water tank base. So the assumption is we have a tank that has capacity of 400 liter and the platform material is made from concrete. So as you can see in this picture is a meshing process. Meshing is a process that divide geometry into multiple elements. It has influence on simulation convergence and accuracy. On this side, you can see the result for total deformation. Before we can get the result, we must determine its pressure that exerted on top of the platform base. From the assumption, 400 liter of water exerted around 400 kilo of mass, and with respect to the area, we calculate the pressure and it found to be approximately 5,000 Pascal. So after we apply the pressure on the top platform, we get the result, which is the maximum total deformation shown in unit meter, and it which equal to 0.00109 millimeter, which is relatively small. This type of analysis tell us that choice of capacity of water tank and the material for platform base is suitable.
Chapter 8 Economic Analysis. Bill of Material. A bill of material BOM is detailed record of all the raw material used in a project. A bill of material is list material needed to make a specific product and is keeping manufacturing of new product Chapter 9 schedule Discussion
as the
and
development
Conclusion.
process.
So concept of prototyping. Generally, the
is
concept is to design and build smart
all
management watering system that can be
item that we
suitable
use
and practicable
in
to be
our
used in planting
product.
area. Smart irrigation system are
There is
designed to
economic
facilitate
analysis on product, the
efficient
study
growth
of
by
economic
watering
system
plant
and
under
production
specific
process is
condition
known
based
as
on user input.
economic analysis.
Our
The
goal
goal
is of the economic
of focus
analysis is to
on
determine how
optimizing
effective
the water
the economy
resources without wasting
is
it,
at
and
producing
this concept
product.
help the
So
farmer
because
when it
of
comes
good
to
is
dry season.
100
Decision techniques such as the
1345
chart
ringgit
between
and
decision
17
metric
and next year
and
is
analytic hierarchy
107.
process. ASP
107.
are used to
So
determine the
we got
best option
profit about
based on the concept that
344
has
ringgit
been
and 30
generated.
cent. And
We
gross
use
profit
the
margin
Arduino as a controller to control the
about
system.
20%. uh, because it's low commercial cost and capability to carry out the fundamental function compared to other microcontroller. The conclusion is, in summary, we develop a smart management planting system that is practical, capable of managing plant growth intelligently and user-friendly. The first objective is to design a smart irrigation system for small-scale farmer based on microcontroller in order to make it easier for rural